Welcome back. We're now going to tackle scrutiny, review, and retractions. Science relies upon a system of checks and balances. This ensures the quality of scientific work, and it double-checks scientific ideas along with the evidence for and against them. It makes sure that the ideas are evaluated fairly. The community evaluates evidence and ideas. Scientific work is reviewed by other scientists during the publication process, and scientists attempt to reproduce and replicate each other's work. This helps to ensure that evidence meets high standards and that all relevant lines of evidence are explored. The community balances biases. Scientists come from various backgrounds. They have different personal beliefs. They favor different hypotheses and theories. And all of that can result in unintentional bias, even when scientists strive to remain objective. The community also helps to identify and eliminate fraud. Although fraud is rare in science, it sometimes happens. The occasional cases of fraud are identified through the scrutiny of the scientific community. So let's revisit the process of peer review. When an author submits a paper to a journal for review, it generally follows this process. The editor will conduct a preliminary assessment, and if it passes, they will send it on to review by reviewers that are experts in the field. That would mean that they have themselves written several peer-reviewed publications, manuscripts, in the area of the submission. The review process can be blinded. Either the reviewers are blinded to the author, or both the reviewers and the author's identities are concealed during the process, or it can be open when all identities are shared with the public. For some publications, the review process is actually interactive, and this means that the authors and reviewers can engage with one another during the review process. Once completed, the editor may then either reject, accept, or recommend revisions to the manuscript, after which it is accepted, produced, and published. But one thing that's very important to understand is that once your work has been reviewed and once it's been published, it gets assessed by the community. Your paper will be read and cited, and some scientists will attempt to reproduce your work. If found to be reproducible, it will become accepted by the community and serve as a foundation for future studies. If not, it can be declared faulty and it may even be retracted or subjected to having an erratum published. But the peer review process itself has flaws. It can take a very long time to get work reviewed. It can cost a lot of money to get work reviewed as well. It can take up to a year to publish your work or paper. The review process can also be inconsistent in that reviewers can often disagree with one another as to the merits of a particular paper. It can be biased. There is strong evidence of bias against women in the peer review process. And in addition, there is bias against negative studies that show negative results are often not published. And the process can also be abused. Ideas can be stolen and presented as your own, or one could be unjustly harsh in a review to block or at least slow down your competitors so that they can't publish before you do. In addition, you can also submit your article in the form of a preprint to a preprint server. It usually resembles the manuscript that would eventually be submitted to a journal for review, but preprints have not been peer reviewed yet. While scientists understand that preprints are tentative, meaning they are not accepted, most non-scientists do not understand that. And while there are many reputable options available, scientists will often discuss preprints extensively before they are accepted as well. Scientists will use this mechanism to share their soon-to-be submitted articles with the community, as the peer review process can take so long. It's critical for time-sensitive research, such as what is happening right now during the COVID-19 pandemic. In addition, scientists can share protocols with one another via services such as protocol.io. And here are some examples of preprint servers that often have life sciences research printed on them in advance. Let's pause here for assignment 2. Welcome back. We started talking about preprint servers a moment ago, but it's important to recognise that the use of preprint servers is increasing. A study by Abdil and Bleckman showed that the number of submissions to bioRxiv exceeded 2,100 in October 2018, with 1.1 million downloads in October 2018. 2/3 of preprints posted before 2017 were later published in peer-reviewed journals, and this shows some of the destinations of these preprints, with the highest being Scientific Reports, followed by eLife and PLOS ONE. In addition, we do have some heroes of scientific integrity. Elizabeth Bick is a full-time investigator of scientific integrity and the public face of image sleuthing. On a given day, she scans dozens of biomedical papers using her eyes, looking for instances in which images are reused or reproduced as if presenting results from different experiments. She can also identify parts of an image that are cloned, flipped, shifted or rotated to create new data. She is a super spotter. In one study alone, she analysed over 20,000 biomedical papers and identified problematic duplications in roughly 4% of them. So she is a hero, and you can follow her on Twitter. Another mechanism is Retraction Watch. Retraction Watch maintains a database of retracted papers. The top 3 papers that have been retracted are shown here, from 2018, 2010 and 2007. The second paper here, by Wakefield et al., is the now infamous paper that links autism to vaccinations. Before it was retracted, this paper had been cited 642 times, and after it was retracted, it was cited a further 780 times. So far, 72 papers have been retracted that deal with COVID-19. This would mean a rate of about 0.03%, which is about lower than the rate across the literature of about 0.04%. The journal Science, though, reported from January to May in 2020, 23,000 papers had been published, and it was doubling every 20 days. A doctor described it as what you would get in a medical conference that used to happen yearly. Now that's happening daily. So the rate of publications has shot through the roof during the pandemic. In an additional study, it's been shown that as many as 137 papers a day since February 2020. The basal retraction rate is about 4 in 10,000 papers, and Retraction Watch database is showing a high retraction record rate for COVID-19 research related.